Good day, class. Today we're going to go over some of the piecewise functions, and I wanted to create this video because I wanted you to have some additional resources so you can look at as we're going through these piecewise functions. Now, one of the first things I want to do is first relate that when we have a piecewise function, the biggest activity that we did is that we realized that not all these functions exist everywhere on our graph. Now, like this one right here in yellow, their first function only exists in a certain piece. It exists only from -5 to 1, which means it only exists in this piece here. And it does not include 1. Now, our next function, 5, only exists in one place, here. And that's this function that's right here. That's the only place it's going to exist, and it's only going to exist in that one line, and wherever the location it talks about. What I mean by that one line, I'm talking about just here. And this one line 1 is the only place it's going to exist, and nowhere else. But I'm going to take the line because we're only going to have one specific location at a specific point. Now, lastly, I want to go ahead and talk about the last one. This one says everything x greater than 1, so that function is going to exist everywhere this way. And I'll draw an arrow so you kind of say that that goes everywhere that way. Now, with all this in mind, let's go ahead and have you graph these. I'll go ahead and pause the video. I want you to graph each one of these. And I'll go ahead and call on somebody randomly to see how they're graphed. Okay, now that you graph these, you should end up with lines that look like this. You should end up with a line that, like our first one, we have a y-intercept of 3. I'll start with the yellow one. So I'll make it, actually I won't make it yellow because it may, I'll make this one, I'll use that one black. And you have, here you have y-intercept 3, and then you go up 1 over 1. So you'll have this kind of pattern. And now what's important is at the ends, like where that domain ends. Now the first one I'm going to look at, I'll look at this part right here, which is on my right hand side at 1. It's not included, so I have to make sure I put an open circle to signify that. That's important because we want to make sure that we follow the rules of what's saying on there. Now on this next part on the left hand side, on its lower limit, it's included in that one, so I'll make sure I put a big dot. And then from there it's a line that connects from there to there. Now the one in purple for my function f of x equal to 5. I'll go ahead and make that one in red, but for that one it's only going to be in one location on that line 1. It's going to be right here. Interesting, it's only in one place because it only exists in the domain in one location. Now our very last one, your graph should look like this. You should have had +2, -x. So let me go ahead and I'll make that one in blue. So that line I'll make in blue. And I'll still draw it on here because I always like to start with y-intercept. And then from there I'll go down. Now what I'm going to do is automatically make an open circle there, just because it's not included at 1. From there you will have a line that goes all the way, I'll make it all the way across, and then draw also an arrow so you can signify that it's going all the way to infinity. Now let's go ahead and answer some of these questions, and some of the solutions to some of these questions I'm going to write it in different notations. And let me go ahead and start with the first one. Let's talk about the domain of the function. Now when I look at the domain of this function, if I look at every x value beginning from 5, there is no break. Even at 1, even though this one has an open circle, and what I'm talking about, even though there's an open circle in these two locations, here and here, there is still a value at 1. And it kind of covered me to change the color at the 1, but what I want to point out is that there's still a value there. So there's no break. There's nowhere we're saying it doesn't exist from 5 on. So what's important for me to write down, and I'll just take away those highlighted parts. It's important for me to write down that in my case, I have my domain. It's going to be, and I'll write it in 2 types of notation. I'll write it in kind of like an interval notation. I went ahead and put 5, from -5 all the way to positive infinity. Now, one thing to keep in mind, when you write this notation, this means included, and this means not included. So you got to make sure you remember that. That's important, because if you don't, you're going to be writing down wrong answers, and I don't want to mark people off for those things. Now, this is not the only way to write it. Actually, let me show you the other way to write it. There's another way to write it that is also in our kind of bracket notation, and where we could go ahead, or you also could write in this kind of form, where x is all real numbers such that x is greater than or equal to -5, because that's what it looks like. That's what it is. Now let's talk about the intercepts. Now there's 3 places that this line intercepts at, and I'll put them in purple: here, here, and here. So I'll have 3 value points. I'll have value -3, 0, value 0, 3, well, not value, point, and 0.20. Those are my 3 locations in where I have these intercepts at. Now let's look at the range. Actually, the range is very interesting on this, and actually I really want to discuss it in detail with you, because with the range is actually curious, because if you notice a couple of things, let me use a highlighter to point some things out. But the range there's actually only one point that exists here at 5, but there's nothing in between. There's nothing in between the 4 and the 5. It's blank. And actually there's nothing that exists again until we begin from 4 below, actually. So from 4 below all the way down to infinity is where my points where I could actually find y values again. So this space that's actually here is blank. There's no values. So there's a break in my range with one specific value. Now that's interesting. That green dot, this part right here, is what I want to focus on. That shows up on the range just as 1 point. 5 included. It's either going to be that, or, and or is actually written in this kind of notation, or it's going to be everything less than 4, but not including 4. So it's going to be, y would be everything less than 4, not including. So that's the other way you could write it. Or, I'm sorry, actually that's not the, if you're going to do it with interval, you got to stay with interval. Let me go ahead and go back and make a correction there. You're gonna go ahead and write it like this: open parentheses 4 all the way to -infinity, open parentheses. That's one way to write it. Or the other way you could write it is a notation where you say ranges all y values such that y is equal to 5, or y is less than -4. Well, actually not -4, sorry, positive. So let's make the correction there. And some of y'all probably caught it, which is great. And if you already stopped me during this video to show me that, I love it. Okay, great. Before I move on, let's see if anybody has any questions. I'll pause the video before I move on. Okay, lovely. Alright, so no questions at hand. Let's go ahead and move on to the next one. And this next one involves this equation here. Now, I'd like for you to go ahead and, now, before a graph, I do want you to do that. So you can do that in the meantime. And one thing I do want to point out to you is just these highlighted parts. That graph is only going to exist from 0 on this way. This one is going to exist only from that location over there. And there's from 0 going that way. Let me draw little arrows there, so you can see that we're talking about going all the way to infinity. Okay, good. All right, let me. What I like for y'all to do is see if we can do this whole thing. I mean, answer this whole question. I'll call somebody randomly to show me the work and see what they ended up getting. Okay, great. All right, now this is what you should have ended up getting. Let me go ahead and pull it up. And put it up in this one. Oop. Okay, right here. Okay. This is what you all should end up getting. You should end up getting this kind of. This should have been your values you ended up getting here. And a couple of things I want to go ahead and point out. When you did this, you had to go ahead and realize the domain of the function, since it encompasses everything, is actually all real numbers. There's actually only one place it intercepts, which is that red dot that's there. And the range of the function is going to be this, it's actually going to be all real numbers too, because if you notice on the y, there's a, since this shoots up that way, the black line shoots up, that means that we have all real numbers everywhere on the y-axis. Okay, lovely. Let's go ahead and move on to the next question and see, and let's go ahead and do that one for you as well. So go ahead and bring up the other one because I want a blank one. And now this one is interesting because it's going to ask us to go ahead and actually write the domain restrictions and also the equations for each one. So it's going to require for us to do two things. First of all, we're going to have to require to come up with 3 equations for the 3 lines and also set their domains. And the domains are going to exist from here to here, from here to here, and also from here to here. So there's 3 areas that I'll be looking at domains. Now I'll start with the first one, which is the yellow one, and we'll move from there. Now, this is what you'll end up getting, okay? We'll end up finding this out. And in my case, my f of x, I'm going to draw this notation because I have 3 equations that's going to be working with. First one I will have is the idea of, I'll start with this one right here, okay? And that one is going to have, first of all, a y-intercept. Well, let's look at the slope first. Slope right there, okay, which means I have a positive 3, rise over run, positive 1, which means I have 3 over 1. 3 over 1x, and if I went up 3 over 1, I'll end up there, which means my y-intercept would have been 5. Now, let's go ahead and talk about the next part of this, which actually has to do with the domain of this. Now, if you notice, you see how this one is included, and I made the dot even bigger? It means that from -1, because this function exists specifically from actually infinity to, from negative infinity all the way to 1. So the way you're going to write the notation, let's go ahead and write it as x. It's going to be then less than all values less than -1. And that one accurately describes that domain. Now let's talk about the next solution. Now the next function is easy to see because that's a constant, so that one's going to be just 4. And the important thing here is the domain values. Now it goes from here to here. And those domain values means that I go from -1, not including that value, x all the way to and including 3. So in my case, that's my domain for just the function 4. Now for the last one, let me go ahead and actually figure out the slope on this one. This is -2, rise over run, -2 over 3. Now -2 over 3, x, let me go ahead and actually figure out what the y-intercept is at. If I go up the other, follow the pattern, there's where it's at. That's my y-intercept. Now let me go ahead and define the domain. Now I went ahead and actually kind of marked in a dot there. I'm going to erase that because I want to see what was really there. And actually notice it was an open circle. So I want to go ahead and actually define that in my domain and write it in my function. And I'm going to go ahead and it goes from 3, not including, so x is going to be all values. And then it stops at 8, but not including 8. That's the reason you see that open circle. So we're going to have from 3 greater than or equal to x, greater than or equal to 8. Okay, great. All right. Now, for the next one, I want you to go ahead and read that problem, and I want to see if you could try to answer that one. I want you to see if you can answer A, B, C, and D, or E, and I'll go ahead and call somebody randomly, and then we'll talk about the problem. Okay. Now that we saw some of these results, let's go ahead and actually talk about the problem. And this is actually what you should end up coming up with. Hold on a second. Here. Okay. Now, first of all, before I get into the problem, you should have realized that for this function, that the time that's played, okay, like first A and B, you're going to see that it matches up with the yellow one, which is $20. So for those, the answer is just $20. C and D actually matches up with the equation that's in purple, So you're going to use that equation to figure out the costs, and you'll find out if you input 140 where the X is, you'll end up with $22 here, and you'll end up with the other one at 180 and $6. Lastly, the last equation, the blue one, has to do with the last one, which is the 200 minutes, and you'll end up with $27 an hour. Okay, great. All right, so I thank you